Okay, so we've already looked at how to prove that triangles are congruent. We've proven triangles are congruent, but we have not yet actually written a full proof. And so that's what we're going to look at today. So we're going to look at what are called two-column proofs. So two-column proof is what it sounds like. We are given some information, and we're going to prove something, and we're going to do so using two columns. Okay, so in this particular problem, which is in your packet on page 63, we are told that segment EN is congruent to segment ET. And we are supposed to prove, that was our given, we're supposed to prove that angle 1 is congruent to angle 3. Okay, so the very first thing I'm going to do is I'm going to mark what's given in my diagram. Segment EN is congruent to segment ET. Now, when we're writing a two-column proof, we're going to have statements. And then we'll have reasons for making those statements. So the first statement is really just going to be what we were given, which is segment EN is congruent to segment ET. And our reason would be we were given that information. Okay, so now let's think about that a moment. Let's think about what that given information tells us. Well, it not only tells us that those two sides are congruent, but we know, because those two sides are marked congruent in a triangle, we know that triangle ENT is isosceles. And the reason we know that is because of the definition of isosceles. Okay, so if we know that it's isosceles, we can use the isosceles triangle theorem, which, remember, says that the base angles of an isosceles triangle are congruent. We can use that to say that angle 2 is congruent to angle 4. So angle 2 is congruent to angle 4 because of the formally it's called the isosceles triangle theorem, but we can just say that base angles congruent in isosceles triangle. Okay, so let's think of what else we know here. Well, we know that angle 2 and angle 4 are congruent to each other, but I'm also noticing that 2 is congruent to 1 because they're vertical angles, and same thing with 4 and 3. So I'm going to state both of those. I'm going to state that angle 4 is congruent to angle 3, and angle 2 is congruent to angle 1. And my reason for both of those is that vertical angles are congruent. Now, I'm just going to use that same reason for both statements. Okay, so I'm going to go ahead and mark that 3 is congruent to 4, so I'm going to put a 1 marking, but 1 is congruent to 2, so I'm still going to put a 1 marking because 2 had a 1 marking. So we can see by looking at our picture, they all 4 of those angles, 1, 2, 3, and 4, are congruent to each other because they all have the 1 marking. Okay, so now let's think mathematically speaking or logically speaking why those four angles are congruent to one another. So we have angle 2 congruent to angle 4, and we have 4 congruent to 3. Well, if I do a little substitution here and substitute angle, if 2 is congruent to 4 and 4 is congruent to 3, basically I just substitute 2 in for 4, and that leads me to say that angle 2 and angle 3 are congruent. So angle 2 is congruent to angle 3. Now, there's a property you learned early on in math called the transitive property, which says if, and that was really just dealing with numbers. So if 2 is congruent to 2 is equal to 2, or x is equal to y and y is equal to z, then that means x is equal to z. Okay, that's generally how the transitive property is explained early on in math. So in this case with angles, if 2 is congruent to 4 and 4 is congruent to 3, that means 2 is congruent to 3, and we call that the transitive property. Okay. Now, similarly, we said 2 is congruent to 4, and no, we said 4 is congruent to 3. Let's try that again. So we have 1's congruent to 2 and 2's congruent to 3, so that means 1 is congruent to 3. Again, by the transitive property. 2 to 1, 2 to 3, that means 1 to 3. So I'm going to still write that under number 5. Angle, I said 1 to 2, 2 to 3, that means angle 1 is congruent to angle 3, and that's again by the transitive property. So we've just proven what we were supposed to prove. Angle 1 is congruent to angle 3. Okay, so that is a 2-column proof. All right. All right, so let's take a look at this other proof on the same page. So in this proof, we were given that RT is perpendicular to ST, and that segment ST is perpendicular to segment TP, and we're supposed to prove that triangle STR is congruent to triangle PTR. Okay, so let's first write our statements column and our reasons. And my first statement is going to be RT is perpendicular to SP and ST is perpendicular to TP. And my reason is that is given. Okay, so let's think about what that tells us. Well, if RT is perpendicular, RT is perpendicular to SP, that means, okay, that those angles are 90 degrees. Okay, well, let's think about how we know that. We know that because of the definition of perpendicular. So we're going to say the measure of angle STR is equal to 90 degrees. And also the measure of angle PTR is 90 degrees. Okay, and our reason is the definition of perpendicular. Okay. Now, it also said that not only is ST perpendicular, or I'm sorry, RT perpendicular to SP, it also says segment ST is perpendicular to segment, whoops, hold on a moment here. We have this a little bit, I messed up here, so let me fix this. It doesn't say segment ST is perpendicular to TP. It says that ST is congruent to TP. So we're going to just get rid of that here. Okay, not a big deal. So we already had the perpendiculars, and now let's list our next given then, since I messed that up. So our next given is segment ST is congruent to segment TP, and that's given. Okay, so let me mark that in my diagram. Segment ST and segment TP, they are congruent. Okay, well, I'm seeing that it's looking like these triangles might be congruent because we talked about this before when we proved triangles congruent. I know that TR is congruent to itself. So now that I've marked it in my diagram, let's write it in the two-column proof. I'm going to say that segment TR is congruent to segment TR. And we know the reason for that. That's the reflexive property. Okay, so now if I'm looking at the top triangle, I see side, angle, side. And the bottom triangle, side, angle, side. Or these are two legs in a right triangle, two legs in a right triangle, so that's leg, leg. So I'm going to say that, and we can look at the statement they give us what we're supposed to prove. Triangle STR is congruent to triangle PTR. Now, if they didn't already give us this congruent statement, we'd have to make sure we had the corresponding parts in the correct order. Our reason is, again, we have either side, angle, side, or if you want to call that leg, leg, because these are right triangles, leg, leg would also be acceptable for a reason for why the triangles are congruent. So we did prove what we were supposed to, and we used the fact that RT was perpendicular to SP and ST was congruent to TP. A little mistake there, but that's okay. So we're finished with our two-column proof. Okay, let's take a look at one more. This is on the next page, page 64. So in this proof, we're told that segment BC is perpendicular to segment AB. So BC perpendicular to AB, I'm going to go ahead and mark that. We're also told that segment FE is perpendicular to segment ED. FEED, okay. We're also told that segment AB is congruent to segment DE. AB, DE. And lastly, we're told that segment AC is congruent to segment DF. Okay, AC, DF. All right, and we're supposed to prove that segment BC is congruent to segment EF. Okay, so let's start with our statements. And our reasons. So we'll put the statements that are similar together here. So we'll put both of those perpendiculars together on the same on the same statement line. So BC is perpendicular to AB, and FE is perpendicular to segment ED, and given. Okay, so I'm going to write what that means. We know. Well, like we did in that other problem, that two-column proof, we have perpendicular lines or line segments in this case. That means the angles created there are 90 degrees or measure 90 degrees. So I'm going to say the measure of, here I can just say angle B. I don't have to use 3 letters because it's clear which one we're talking about, is equal to 90 degrees. And while I'm at it, I'm going to go ahead and say that the measure of angle E is 90 degrees. Our reason for that is knowing what the definition of perpendicular says. So if those angles measure 90 degrees, then they're congruent. So I'm going to say that angle B is congruent to angle E. My reason is the definition of congruent. Okay, so we have angles that are congruent. We're also going to state what else we know. So we can go ahead and put those sides that we were given. AB congruent to DE, and also AC congruent to DF. And those were given. So I'm looking at my triangles now to see if I can prove that they're congruent. Well, I have 2 sides and an angle, and the angle's not in between the 2 sides. So generally 2 sides and an angle is not enough to prove the triangles are congruent, but these are right triangles. Okay, so we do have when we have 2 right triangles, remember we can prove them congruent using just 2 pieces of information. So we're going to first state that these are right triangles. Triangle BCA and triangle EFD are right triangles. And how do I know that? Well, that's the definition of right triangles. Okay, so because they're right triangles, then I only need 2 pieces of information along with the fact that they're right triangles, not 3. So we have our given sides that are congruent, and we know that they're right triangles. So I'm seeing I have a hypotenuse and I have a leg in both triangles, a hypotenuse and the leg. So I'm ready to say that the 2 triangles are congruent. I'm just going to continue my statements and reasons over here. So 6 is triangle BCA is congruent to triangle. Let's check my order here, starting with E. I did BC, so that means EF, and then D. And my reason is hypotenuse, leg. So I already said they're right triangles, and the hypotenuse is congruent and the legs are congruent. Therefore, the triangles are congruent by hypotenuse, leg. Okay, so now let's see if we've proven what we need to. Not quite yet. We weren't just supposed to prove the triangles are congruent. We're supposed to prove that segment BC is congruent to segment EF. Okay, so we actually do know that because the triangles are congruent. There's a theorem which says that the corresponding parts of congruent triangles are congruent. Now, we actually already knew that. We didn't necessarily know it in those words, but we knew that if we had triangles that are congruent, we have those 6 pieces of information that we know. The angles, the corresponding angles are congruent, and the corresponding sides are congruent. So another way of saying that is that the corresponding parts of congruent triangles are congruent. So that's our reason for our last statement here, which is segment BC, which is a side of the left triangle, is congruent to its corresponding side, which would be, I'm going to be sure to go in the correct order, so EF And my reason is corresponding parts of congruent triangles are congruent. Short way of writing that is C, P, C, T, C. Corresponding parts of congruent triangles are congruent. So we're done with our two-column proof. We have proven that segment BC is congruent to segment EF.